Alright, in this video we are going to talk about Unit 5, Objective 5, improper integrals. So what an improper integral is when an integral has at least one limit of integration of infinity. So there's three different cases that we can be looking at. The first one would be f is continuous on the interval of a to infinity. And if that's the case, the integral from a to infinity of some function, what we're going to end up doing is replacing the infinity in our upper limit of integration with some variable b. Then we're going to take the limit as b goes to infinity of that integral. Similarly, case 2, if we're going from negative infinity to b, then we're going to replace negative infinity with a, and we're going to say the limit as a approaches negative infinity of the integral from a to b of f of x dx. And there's actually a small typo. This should say a approaches negative infinity on your limit. So we're replacing the negative infinity and taking the limit as a goes to negative infinity. And then for case number 3, if they want us to find the integral from negative infinity to infinity, we're going to pick any number c that's in between negative infinity and infinity. Easiest case is probably going to be 0. And then we're going to take the integral from negative infinity to 0 and then add to that the integral from 0 to infinity, or any c value that you choose. And then we have a case in the second part for case 1, case 2 in the first part, and we're just going to add those things together. Now for cases 1 and 2, we're going to say the integral converges if the limit exists. Otherwise, we're going to say the integral diverges. So converge means we're going to get an answer. Diverge means we are not going to get an answer. Now for case 3, we have to have both of those things converge if we're going to get an answer. So let's take a look at a couple of examples, see what this kind of looks like. So this first one, the integral from negative infinity to infinity of e to the x dx. So the first thing that we want to do is split this up, because we have case 3, we have negative infinity to infinity. So we want to think about this as the integral from negative infinity to, like I said, I like to pick 0 because that's the easiest one, dx plus the integral from 0 to infinity of e to the x dx. And now we want to take each of these things separately. So for this first one, we're going to want to write this as a limit as a, since it's our lower limit of integration, goes to negative infinity of the integral of a to 0 of e to the x dx. And then for this second one, we're going to say plus, and we'll move it over here, the limit as b approaches infinity of 0 to b of e to the x dx. So we want to kind of ignore the limit and just take our integral here. So we know that the antiderivative of e to the x is e to the x, and we're going to have to evaluate from a to 0. And we want to take the limit of that as a approaches negative infinity. So limit as a approaches negative infinity of e to the 0 minus e to the a, which would be the limit as a approaches negative infinity of 1 minus e to the a. If we plug in negative infinity, we're going to get 1 minus 1 over e to the infinity. Right? Negative infinity brings our exponent and the variable down to the bottom. E to the infinity is some huge number. 1 divided by that huge number is going to be 0, so we're looking at 1 minus 0. So this first integral, the integral from negative infinity to 0 of e to the x dx is 1. So if we look at the other one, same idea. We're going to be looking at the limit as b approaches infinity. Our integral is going to be the same thing, e to the x from 0 to b this time though. So we're looking at the limit as b approaches infinity of e to the b minus e to the 0, which is the limit as b approaches infinity of e to the b minus 1. Plug in infinity, we get e to the infinity minus 1, which is infinity minus 1, which is infinity. So the left side converged, the right side, we didn't get an answer, we got infinity. The right side diverged. So if we have 1 plus infinity, well, that's going to be infinity, so this diverges. So we have a divergent improper integral. And if you think about what this means in terms of integrals, it should make sense. E to the x looks like this, and this continues to grow forever. If we're finding the area under this curve from negative infinity all the way to infinity, that area is going to be infinitely large. So that's what we mean by divergent. We're going to get an infinitely large area. So there's one more example I want to look at, and then we'll call it quits on the video. So for this example, we are only doing the one side. So we can go ahead and just rewrite this as the limits as b approaches infinity of the integral from 1 to b of x e to the negative x dx. So the issue with this one, and I don't believe AP will give you something like this, but the issue here is we need to use integration by parts. Right? We can't use a u because u would be our negative x, du would be negative 1 dx, and I don't have a negative 1 dx, I have an x dx. So we have to use integration by parts. So if you remember, we got to pick our u for integration by parts based on limit. So we don't have any natural logs, we don't have any inverse trig, we do have a polynomial x. So we know u is going to be equal to x, which means dv is going to be equal to e to the negative x dx. So take the derivative, du equals dx. Take the antiderivative, v is going to be equal to negative e to the negative x. So it's not just e to the x, because we have this little thing here, so you'd have to use a u substitution. U would be negative x, du would be negative dx, so that's where the negative outside of our e to the negative x comes from. So we can look at this now as saying the limit as b approaches infinity of uv, so x e to the negative x, evaluated from 1 to b, minus the integral from 1 to b of v du, so negative e to the negative x dx. We can take this negative sign here, bring it out front, so the limit as b approaches infinity of x e to the negative x evaluated from 1 to b plus the integral from 1 to b of e to the negative x dx. If we're going to integrate this, we need to use a u substitution because that's not just x, it's negative x. We're actually going to kind of cheat here a little bit. So we're going to make our u substitution. So we're going to say u equals negative x, du would equal negative dx. So we're going to pull that out front. So the limit as b approaches infinity of x e to the negative x 1 over b, this turns back into a minus sign, 1 to b of e to the u du. And here's how we're going to cheat. We're not going to find new limits of integration. Normally we would, but now we have a variable and it's going to get really messy if we try to do it that way. So we're going to kind of cheat. We're going to take the integral of e to the u, which is just e to the u. But, actually let's go ahead and move that over here real quick. Instead of evaluating e to the u of 1 to b, u is a u value, 1 and b are x values. So we're actually going to go back to the negative x. That way we don't have to change our limits of integration. So our limit now is going to become the limit as b approaches infinity of x e to the negative x evaluated from 1 to b minus, right, because this is a minus sign again, e to the negative x evaluated from 1 to b. So let's evaluate these things from 1 to b. So the limit as b approaches infinity of b times e to the negative b. E to the negative b is 1 over e to the b minus 1 times e to the negative 1, so that's really just 1 times 1 over e, minus, and then let's make sure we put this piece in parentheses, and really we should put brackets around this. E to the negative b is 1 over b. I'm sorry, 1 over e to the b. Like that, 1 over e to the b, minus e to the negative 1, so that's 1 over e. We can simplify this a little bit, combine some like terms here. We're going to say the limit as b approaches infinity of, we have negative 1 over e. Just realized I made a mistake all the way at the beginning, but it's going to be an easy fix. When we have uv, u was negative e to the negative x. So all of these things become negative, which means this b over e to the b is going to be negative, and this 1 over e is going to be positive. So when we go to combine our like terms, we have a negative b over e to the b minus 1 over e to the b. We have 1 over e minus negative, so plus 1 over e, so that's going to be plus 2 over e. Then we evaluate, and we plug infinity in. E to the b is an exponential. It's going to grow faster than negative b minus 1. So this term here goes to 0. We have 0 plus 2 over e is 2 over e. So like I said, I doubt AP is going to give you an improper integral where you have to use integration by parts, but that's what it would look like. So that'll do it for this video. We will see you in the next one.